Hey y'all, it's me, Miss B. Today we're talking about solving applications of trig functions. So we're going to just do a couple definitions here. But the main thing I'm going to tell you today is that you need to draw a picture for a lot of these problems. A lot of you are reluctant to do that, but that is the best way to be successful in this section. So when solving for the sides and angles of right triangles, the sides are going to be rounded to the nearest tenth, and the angles are going to be rounded to the nearest degree, and that's the nearest whole number. Okay, and then also just remember the inverses find angles. That's something we talked about before. And something maybe we didn't talk about that's really important is not to round until the end. Your answers, if you round before the very last step, will be close, but they won't be absolutely correct. So make sure you don't round until the end. So we're going to use trig functions to do these. We've already kind of talked about it, but I do want to do a few examples just to remind you. So I have 34.5 degrees of A, and then I also have A, and then I'm looking for side A, angle B, and angle C. Now, the angle is going to be the easiest thing to find because angle A plus angle B plus angle C is going to be equal to 180 degrees, right? That's what we know about triangles. So A is 34.5, B is unknown, and C is 90 degrees. And that's all equal to 180. So if I do some math here, I'm going to add 90 and 34.5 and get 124.5 degrees plus angle B equals 180. Then I subtract 124.5 from both sides and I get angle B is equal to 180 minus 24 would give me 55.5 degrees. Let's check. So that's 5, 6, and okay. Why do I feel like that's wrong? No, I think we're good. Okay, so that's 55.5 degrees. All right, and then I'm able to find these other sides using other things. And this is not a rounded value either, which is important. So let's go ahead and do, we're going to use this angle here and this side here. So, and we'll find A. So I have the opposite, I'm looking for the opposite side. I have the adjacent side. So I'm going to use tangent of that 34.5 degrees is equal to A over 10.5. Now we have to remember to put our calculator in degrees as to not make any mistakes. So I'm going to go ahead and pull up my calculator. I might have to search it. Okay. So we have tangent of 34.5. My calculator is in degrees. And then that is going to be, if I multiply by 10.5 on both sides, that will give me A. So take tangent of 34.5 and multiply it by 10.5. And I get 7.2 units. So A is equal to 7.2 units. Now, because I used a rounded value, I don't want to use that value to find any other values. So instead, I'm going to do another calculation. So using the same two sides I already had, so this, we'll use a different color here. So I'm going to use this side and this side. So I have the adjacent side and the hypotenuse I'm looking for. So that's going to be the cosine. So cosine, and we'll just do that up here. So cosine of 34.5 degrees is equal to 10.5 over c. So if I multiply both sides by c, I get c times cosine of 34.5 equals 10.5. And then if I divide by cosine on both sides, I get c equals 10.5 divided by cosine of 34.5. So I'm going to go ahead and plug that into my calculator, making sure that it's in degrees. So we get 10.5 divided by cosine of 34.5. And I get 12.7. So C is equal to 12.7. And that is units. Want to make sure we label, especially the degrees and all that good stuff. So I have found A, B, and C successfully. That should have been pretty easy, except you're just finding more than one side than we are used to doing in the past. This next one here is a little bit more involved. I appreciate it because it's a little bit of a mind bender. So I'm looking for x. That's all I'm looking for is this side over here. In order to do so, though, I need to find this and this and then add them together. So just something I want to point out, if this is 90 degrees, this is also 90 degrees. And so let's go ahead and just focus on the top half. So I'm actually going to white out the bottom half just to eliminate any confusion that we might have. Okay, let's call the blue A. And we'll eventually have A plus B is equal to X. Okay, so A, we've got an angle, and then we have the adjacent side and opposite side. So that's going to be the tangent of 20 degrees is equal to A over 100. So then A is equal to 100 times tangent of 20. Okay, and then I'm going to go ahead and now white out the top. Remember, we don't want to round until the very end, so I'm not even going to give it any time of day. So I'm going to white out the top here. And I'm going to call this part down here B. And this side over here is 100. So what we end up having is we have an angle, we have the opposite side, and we have the adjacent side again. So I'm going to have tangent of 8 degrees this time equals B over 100. Okay, so then I'm going to erase that. Oh, and then I want to multiply both sides by 100, so I have B is equal to 100 times tangent of 8 degrees. Now remember, we don't want to round to the end, but I know that X is equal to A plus B, so it's equal to 100 tangent of 20 plus 100 tangent of 8 degrees. And let's go ahead and plug that into our calculator. So we have 100 tangent of 20, and that is in degrees, plus 100 tangent of 8. So I have that my side is equal to 50.45 or rounded to 50.5. So X is about 50.5, and we'll put that in units. Okay. So that's a multi-step problem. As long as we know our trig functions, we should be good to go. All right, now here's where the drawing comes into place. It says from a point on level ground, 125 feet from the base of a tower, the angle of elevation is 52.7 degrees. Approximate the height of the tower to the nearest foot. So here I'm going to draw my level ground, and that's 125 feet. And here's my point, and then here's my tower. You can get fancy with it if you want to, or you can just draw a plain old triangle and label it. All right, and then the angle of elevation. Now the angle of elevation is going up to the top of the tower. So this right here is our angle of elevation, and it is 52.7 degrees. Now I want to approximate the height of the tower to the nearest foot. Now, unless it's the Leaning Tower of Pisa, it's going to be a 90-degree angle right there. And so I need to find the tower, which we'll call X. Go ahead and solve that on your own. What you should have said is we have tangent of 52.7 degrees equals x over 125. Multiplying both sides by 125, we get 125 times tangent of 52.7 degrees is equal to x. 125 tangent of 52.7 gives us 164.08. And it says to the nearest foot, so we're actually just going to write 164 feet since it asked for that to the nearest foot. So that is our answer. Okay, next up, it says you're taking your first hot air balloon ride. Your friend is standing on level ground. So here's my friend. And they're standing on level ground. And they're 100 feet away from the launch point. And so we'll just have our hot air balloon here. At one instant, the angle of elevation to your friend, to your terrified face, is 31.7 degrees. So at some point, let me make this a little bit better. So at some point, this is where you are, because your hot air balloon just keeps rising. And that angle of elevation is 31.7 degrees. Then a minute later, the angle of elevation is 72.6 degrees. So from here to here, that's 71.6 degrees. And it's saying, how far did you travel to the nearest tenth of a minute? Now, a lot of people are going to do 71.6 minus 31.7 and then do whatever calculation. That's wrong. Don't do that. Instead, we need to do two calculations. So I'm going to call this whole side X, and this little side right here, you know what? I'm going to color coordinate. I'm going to call this whole side X, and then this little side Y. Hopefully it's obvious that that is just what I'm talking about. Y. There we go. So let's find Y first. So I'm going to have tangent. So I'm going to have tangent of 31.7 degrees equals Y over 100. So then Y is equal to tangent 100 tangent of 31.7 degrees. Then let's find X. So I'm going to have tangent of 71.6 degrees is equal to 100, or x over 100. So then x is equal to 100 tangent of 71.6 degrees. Okay, this one's different than the other ones because it's asking for the little distance. So it's going to be x minus y is equal to our answer. Now, x minus y is equal to 100 tangent of 71.6 minus 100 tangent of 31.7 degrees. So we'll go ahead and type that into our calculator. So 100 tangent of 71.6 minus 100 tangent of 31.7. And we get 238.8. And it does tell us to round to the nearest tenth of a foot. So it is, I already forget, 238.8 feet. Oh, I'm on the wrong side here. That's equal to 238.8 feet. Okay, now let's talk about trig and bearing. So in navigation surveying problems, the term bearing is used to specify location of a point relative to another. Now, relative means in relation to or in reference to. Just keep that in mind. So here, I'm wondering, what is the... let's change that. So what is the bearing from the origin to A? Now we always start at north or south. And the reason for that is because we are talking about direction. So the bearing from O to A, and that's actually going to be for all of these, so I'm just going to move that. Then what we're going to do is we're going to say, okay, we're north and we want to come here. So we're going to do northeast is the angle, but what's the thing that goes in between here? Now we have to find this angle right here. So 90 minus 55, which is 35, gives us north 35 degrees east as that bearing. Okay, now from O to A on this one, I can start south. So south, and then 90 minus 55 again, which we already did, is 35 degrees. It's going to be south 35 degrees east. Okay, so we're always looking for the north and south pole when we're talking about direction and bearings. So I'm going to go ahead and draw an angle south 30 degrees east. So here's south, here's east. I know my angle's somewhere between then. And so I'm going from south to east, and that's going to be where my 30 degrees is. We don't necessarily have to draw that angle there. I'm going to just draw, because we always draw our angle here. This is south 30 degrees east. Okay, you can label it if you want to, but it's really not necessary. Okay. Now, that was just an intro so we can solve problems that use bearings. So it says a ship is due west of a lighthouse. So I'm going to just draw a little box and put an L in it for a lighthouse. Now the ship is west of that, and it's due west, so here's our ship. And that's the first ship. A second ship is 12 miles south of the first ship. So here is the ship. This is 12 miles. And here's the second ship. The bearing from the second ship to the lighthouse, so from here to here, is north 64 degrees east. So from here, this is like our origin to the lighthouse is north 64 degrees east. And so now we need to find the second. Okay, so this is 64 degrees here because it's northeast, and that takes us to the lighthouse. That's 64 degrees. And then it says how far to the nearest tenth of a mile is the first ship from the lighthouse. So we are trying to find this distance right here. Okay, so the way that we're going to do that is by saying we have this angle here, and we're looking for these two sides. Now that is going to be, and this is a right angle. So what we have is we have our side, and then we have the opposite and adjacent sides. So we have tangent of 64 degrees equals x over 12. So then x is equal to 12 times tangent of 64 degrees. All right, so we'll type that in our calculator. 12 tangent of 64. My calculator's in degrees, so we get 24.6. And it does ask for the nearest tenth of a mile, so 24.6 miles. And we do want to label our answer. Okay, so that is why the bearing is important. It kind of gives us the direction and where to go from there. All right, finally, we're to simple harmonic motion. An object that moves on a coordinate axis is in simple harmonic motion. If its distance from the origin d at a time t is given by either d sine, and this is omega t, or d cosine of omega t, which starts at max displacement. So the one with sine begins at rest, and the one with cosine just begins at max displacement. And that makes sense because normally cosine starts at 1 and sine starts at 0. So it's starting at its max point for cosine, and its sine, it's starting at that resting point. The motion has an amplitude absolute value a, which is the maximum displacement of the object from its rest position. The period of motion is always going to be 2 pi over omega, where omega is greater than 0. The period is going to the period gives the time it takes for the motion to go through one complete cycle. Now, frequency is different than the period. Frequency is the number of cycle or periods completed in a time frame, whereas the period is the amount of time it takes. Okay, but they are related because frequency is the inverse of the period. So frequency is omega over 2 pi, which, or b over 2 pi, and then frequency is 1 over the period, which is then our inverse. So we're going to write an equation for the distance of an object from its rest position after t seconds. So if its distance at rest is 8 inches, that means it's starting at its max displacement, which means we are going to use the cosine function. So we're using d cosine of omega t. All right, d is our max displacement, which is 8. Cosine is always cosine, and then omega is going to be, the period is equal to omega over 2 pi, right? No, 2 pi over omega. Got them flipped. And we have that the period is 2 seconds and 2 pi over omega. So then we have 2w equals 2 pi. Divide both sides by 2, we get divide both sides by 2. And we get omega equals pi. So then 8 cosine of pi t is my answer because this is equal to that. Okay, this next one here, it's starting at rest, so we're going to use d sine of omega t. Okay, let's use that equation again. So we have the period is equal to 2 pi over omega. The period is 2.5 this time. We've got 2 pi over omega. Let's clean that up a bit. 2 omega equals 2.5 equals 2 pi over omega. So 2.5 equals W, omega equals 2 pi. Divide both sides and we get, we'll divide both sides by 2 pi, 2.5. So omega, and we're just going to do 2 divided by 2.5 in our calculator. And we get 0.8, and then you can turn it into a fraction. You should know that fraction. It is 4 over 5. And we want to leave it in terms of pi, so this is 4 pi over 5. So our final answer is written as 5 sine omega is equal to 4 pi over 5 t. All right, and then sometimes it's going to give us an equation. We have to find the information. So given 12 cosine of pi over 4t, what is its max displacement from rest? It's going to be that d value, which is 12. The time required for one cycle. So that is asking what's the period. Just ask it in a funny way. So to find the period, we're going to take 2 pi divided by this value here, so pi over 4, just like we always have. That's nothing different than we've done in the past. So we have 2 pi times 4 over pi. Pi's cancel out, and we get 8. So 8 seconds. And then this is in centimeters because it gives us centimeters here. And then the frequency, if you remember, is 1 over the period. And our period is equal to 8, so we get 1 over 8. Frequency is 1 over 8. All right, that is